Hey, Jody here with WeldingTipsAndTricks.com. I got an email recently from a guy who's having trouble passing a 2-inch 6G weld test, TIG root. Okay, a 6G weld test is on a 45-degree angle like this, and it's a very common test. It's a little bit difficult because usually one side is a lot easier for you than the other because you either have to swap hands or contort a little bit, and also because the bottom half you're fighting gravity on that TIG root. Now, most specifications call for flush or a little bit above flush on the inside, and that's not all that easy to do. You go a little bit too hot or hang around too slow, and it'll suck back, they call it. Basically what happens is just the puddle is too fluid, and the surface tension isn't there, and gravity pulls the puddle downward and makes it below flush. Now, it is possible to have it above flush. There's all kinds of techniques, there's all kinds of ways to skin that cat. There's a technique called backfeeding where you feed the rod through the pipe. Usually backfeeding requires quite a wide gap, like at least 5/32 and even wider sometimes. Well, I've been to some test shops where they wouldn't allow anything wider than a 5/32. 1/8 of an inch plus or minus a 32nd, that's all. And even sometimes they specify the size rod. So, you know, you want to be able to do it a few different ways. But it is possible to use certain techniques that'll help you push a little metal through on the bottom and make that root pass acceptable. And that's what we're talking about today. I'm using these are test coupons from Triangle Engineering. Thank you to Triangle Engineering for providing these. But I set the machine today using some plates that they provided. 37.5-degree bevel plates. Now the question is, will the settings transfer? They should. Why wouldn't they? One's round, one's flat. But this is 3/8 inch thick, and the wall thickness on this is not nearly 3/8. It's only it looks like a couple hundred thousandths. We're going to find out today whether the settings that I dialed in using the plate will transfer over to the root pass on this pipe, and we'll talk about two different techniques that I use, two totally different techniques, a dip keyhole and a lay wire with a straight forward and back technique. And then also, because amperage is such an important thing, what do you do if you're training on one machine at school and it says 90 amps and that works for you perfect every time, and then you go to a totally different machine at the test shop, maybe it's just got a bunch of scratches on it where previous welders have marked their sweet spots and you can't even make out the amperage on there. What do you do there? Well, I got a little tip for you on how to tell amperage from one machine to another, a down and dirty tip, and so let's do it. All right, I'm tacking together some of these 3/8 inch thick plates from Triangle Engineering. They're 37.5-degree bevel. I've got pretty much zero land on there. You can see I've got the mill scale cleaned off a good 1/4 inch back from where the weld's going to be. And the first one I'm going to tack up with a little bit loose 1/8 the gap. That's 3.2 millimeter gap, but it's a little loose because I'm going to use it for the dip keyhole method. So tacking it up, just packing some rod in there. I want to get a kind of a heavy tack on here because if you don't get a kind of a heavy tack, it can really close shut with you a lot. So I'm feeding a little extra dip a rod or two, and I'll get another tack here after massaging that a little bit just to make sure it's just a kind of a loose 1/8 where I can get a 1/8 rod in and out of there pretty easily. And this is the Triangle Engineering test stand that's made for doing plate tests and pipe tests in 45-degree positions or overhead or vertical or horizontal or whatever. Very versatile thing. So I'm going to swing it around here. You can see I've got the plate positioned at a sort of a halfway between overhead and vertical. So I know if I can push a root pass through that, that will kind of be like coming off the bottom of a pipe. That's my thinking anyway. So I'm going to take just a few dry runs here, and notice that I got kind of a small cup on there. I believe this is a number 5 gas lens cup. I've got a stubby gas lens kit on this 17 air-cooled torch, but that's kind of small, and if you use too small a cup on an open root like this, you can suck air in there and get porosity. So I'm going to bump it up to a 7 or 8 here, and that way I won't have a lot of argon streaming out of there and drawing air in around where it's pushing it through that gap. Should work out better for me. Alright, so first up is the dip keyhole technique. Now these are the specs that I use on it. 1/8 to 5/32 gap with a 3/32 rod and 0 land. You can pause, rewind, or whatever and look at that, or you can go to the article on my website if you want to be reminded of the scheme of the fit up here. Now this, you see the keyhole there is starting to get just a little bit wide. That's about as wide as you want that keyhole to open up, and you want to keep the rod in there often and push a little rod in there each time you put it in there. That's kind of the key to getting a little reinforcement on the back side of the root. Keep the rod in there often and push a little extra in there. Don't get crazy. If you push too much, you'll have bare unmelted wire on the back side. But you can see that's a little above flush. Kind of not really all that smooth, not as smooth as lay wire would be, and lay wire is coming up next. Here's a little bit different scheme. 1/8 gap, 1/8 rod. 3.2 millimeter gap, 3.2 millimeter rod. And I just lay the rod in there and no side to side motion at all. Straight forward, straight back. This is 90 to 95 amps and it worked out pretty darn well. I'll give you a view from the back side. You should be able to kind of get an idea of how quickly it's going in there. I'm motoring on at a pretty decent rate here. It's one thing I like about it, but you do have to have the fit up right, the amperage right, and everything's got to be fairly close to be able to do the lay wire thing here. And it goes at a fairly quick speed too, so you know, if there's a bunch of stuff in your way in the field, that's why it's kind of tough to do if there's obstacles in the way, because you do have to motor on. But it works really well. Give you a little view of the back side of that here pretty soon. You can see it looks a whole lot better than the lay wire technique did. Here we go. And also push through really nicely. That was at 95 amps. That's a good, probably a good 50 thousandths of thickness sticking through the back side there. We don't care what the front side looks like, but I will say that those little islands of silicon from the filler metal, you kind of want to get those removed before you came back with a second pass. Now I wonder if it'll work on 1/8 inch thick. 1/8 inch seems a little thin for the same amperage to work on, but I put the same bevel, same gap here on 1/8 inch thick metal, and I'm going to position it in the same position just for kicks to see if you could dial root setting in using something as thin as 1/8 inch. And we'll see in just a minute. I've got about the same bevel on here with very little land, and so I'm going to tack it up, put it in the same position, sort of halfway overhead, halfway vertical, and using a 1/8 rod, I'll fire up on it and use the same exact technique. Nice close arc length, and straight forward and straight back, no side to side motion. This is real time speed here, so you can see it's going on at a fairly good little clip, but it's pushing it through there. And if I hang up too long on something this thin, the heat will build up and it'll keyhole out. But if I can keep my speed going, that same 90 to 95 amps works even on 1/8 inch metal with that same bevel and same gap. Now this is what I did. This is on thick metal, but this is pretty much how it looked using on that 1/8 inch thick metal. But it pushed it through the back side. There's reinforcement there. It's not sucked back. It's not below flush. It's poking through a little bit. So if you do things right and you get the right fit up, you can benefit from the arc force of that TIG arc, and it'll actually push the root through the back side. But you do have to keep a little pressure on that filler rod. Second pass, you also want to keep a little pressure on the filler rod. If it wants to take some rod, you want to feed it the rod. Otherwise, you can suck back with the good that you did on the root pass. So I'm coming across with the second pass, just propping here, not walking the cup, not spending much time across the middle, and that's what that looks like. All right. Well, 90 to 95 amps seems to be the magic number for open butt root passes with a 37.5 degree bevel. So I'm going to go ahead and just verify that same setting will work on something with this wall thickness. Same bevel, almost no land, and same gap. And I'll tack it up using a 1/8 gap, using a 1/8 filler wire here. And we'll speed things up drastically here, just because it's kind of boring to watch making tack welds. Once I get this thing tacked, I'm going to put it back up in the test stand on a 45 degree angle, and I'm going to set it up where I'm going to show you the bottom here. I'm really concerned about whether or not this thing pushes through on the bottom. I know it will on the top. So that's what it looks like coming off the bottom. Same technique, 90 amps. And it pushed it through just a little bit above flush, fairly even all the way around. So it worked. Alright, well, here's the down and dirty tip for being able to set amperage on a machine that's strange to you to make it weld like the one you have been training on, or the one you're accustomed to. And it's all based on spot size, the size of a puddle that a machine will make at a certain amperage for 3 seconds. So puddle for 3 seconds at a certain amperage, and then adjust the amperage again and puddle for 3 seconds. And I'll whiz through this because I can already sense eyeballs rolling already. But I'm going to do 70 all the way up to 120 amps. Like I said, counting to 3 seconds each time on a nice piece of clean cold rolled steel, sanded nice and clean. And what I'm going to have here is I'm going to have a reference piece, because a Dynasty 280 is pretty accurate on the digital readout and everything. So now I've got a little reference piece from 70 to 120 amps that I can use now to take a machine that doesn't have a digital readout, or a strange machine that got maybe a pair of vice grips on there and nothing else, or maybe a bunch of scratch marks and all the amperage marks have been scribbled out. And I'll puddle this one for 3 seconds, and then I can compare the diameter of the puddle made at 90 amps on a machine that I know is pretty close. I can measure that. And by the way, 90 amps gave me about 150 thousandths wide puddle, or 3.8 millimeters. And now I can take that same measurement, and I'll just leave the calipers set where they were and compare to what I just did with that Lincoln that didn't have the digital readout. There's kind of like almost a little bit of guesswork involved. And it's pretty darn close, just a hair difference. So that's just a tip. You know, it's just like if you're going to take a welding test somewhere, you could easily get a piece of scrap metal, clean it off, and by knowing what 90 amps gave you on the machine you were familiar with, you could then adjust the machine accordingly wherever you were at, and it would weld pretty close to the same. Alright, well, that took all day long, and I am tired now. I need to go get some rest. Alright, like I said, I could sense the eyeballs rolling in the back of the head when I'm talking about verifying amperage by spot size here of width of a puddle. But anything you can do to help your nerves and know that you can pretty much parachute into any test shop, set a machine to where it welds like the one that you're accustomed to, can help. I know what it's like to hop in a car, drive for a long, long way, take a welding test, then have to make the phone call, honey, I didn't make it. I don't know how we're going to pay the bills next week. You know, yeah, it sucks. So anything I can do to help, glad to do it. See you next week. Well, hey, listen, if you've got a suggestion on how you put a root pass in to get some reinforcement on the bottom of that pipe, feel free to leave a comment here. Hit that subscribe button if you want, and visit the store at weldmonger.com.